Hello and good day. Welcome to Oscar's Lab. So today we'll be talking about tornadoes. So we are going to have three experiments about tornado and about the water pressure. So first things first, we are going to do the water bottle tornado. So all we need is this. Now we have here now the empty water bottle. We put some water on it, and we have another empty bottle, and we'll be needing the bottle connector that you can buy in any toy shop. Now there's a lot of styrofoam. That depends on you if you want to put some styrofoam on it so that it will be more dramatic. Now you need to connect it together. Now we are going to experiment about tornado. So tornado is all about two different air.
Rising air is the first ingredient needed for a tornado to develop. Any storm is formed when condensation occurs. The byproducts are the clouds. Condensation releases heat, and heat becomes the energy that drives huge upward drafts of air. The more condensation and the come. In supercells, this rising air mass is particularly strong. As the air climbs, it can change direction and start to move more quickly. Finally, at the storm's base, if there is a lot of moisture, a huge cloud base develops, giving the tornado something to feed off later, if it gets that far. When all these things are in place, a vortex can develop, enclosed by the storm, and forming a wide, tall tube of spinning air that then gets pulled upwards. We call this a mesocyclone. Outside, cool, dry, sinking air starts to wrap around the back of this mesocyclone, forming what's known as a rear flank downdraft. This unusual scenario creates a stark temperature difference between the air inside the mesocyclone and the air outside, building up a level of instability that allows a tornado to thrive.
So this is how it works. So we have here the water bottle. Now all you need is just like what's happening whenever you flush the toilet. You will see like a swirling thing. So all you need to do is to twist it and shake it, and you're going to form a big swirling tornado all the way there. So as you can see, the water goes here, and you can do it again on the other side. Now I made a bigger tornado. So this is the tornado that sucked Dorothy and her house all the way all the way to Oz. Now I'll be showing you this one. I bought it on online, the Amazon. So this is how it works. So we are going to pretend that this is our this is the air up here. This is the cold air, and this is the hot air. Now when the wind
downdraft. This unusual scenario creates a stark temperature difference between the air inside the mesocyclone and the air outside, building up a level of instability that allows a tornado to thrive. Then the mesocyclone's lower part becomes tighter, increasing the speed of the wind. If, and that's a big if, this funnel of air moves down into that large, moist cloud base at the bottom of the parent storm, it sucks it in and turns it into a rotating wall of cloud, forming a link between the storm that created it and the earth. The second that tube of spinning cloud touches the ground, it becomes a tornado.
Pressure and air. Swoop. Okay, now we are going to try to talk about Air pressure. So we need a bottle and a straw. You need to punch a hole here on your bottle and take the straw, put it there, and of course put some glue on your straw. Then we'll be putting some water on it. Now we have water on the bottle. Then, of course, we need some cup here, and we need cover and balloon. So you need to cover your bottle. Then you need to inflate the balloon. Now we are going to put it on the top of here in our bottle. Now let's see. We're going to release the balloon and see, the air pushes the water to go out. So this is what we call the air pressure. So thank you very much. See you again next time. So I hope you've learned a lot today. See you again next time. Oh, remember, it's always fun to be a smart kid. So this is Oscar from Oscar's Lab. Bye.